Hi, my name is Pena, and I'm Park Hill's young astronomer, and welcome to the 2004 Science Fair. And today we're going to look at telescopes and how they work. A telescope is an instrument that magnifies distant objects. A telescope can also produce images of objects that are too faint to see with the unaided eye. Astronomers use telescopes to study planets, stars, and other heavenly bodies. A pair of binoculars is actually two telescopes joined side by side. There are telescopes in large dome-shaped buildings on the surface of the Earth, and also telescopes in artificial satellites in orbit around the Earth. Space probes that journey to other planets also carry telescopes. Do you want to go look outside and see how a real telescope looks? Great, let's go! Hi, we're back from my room and now we're under the beautiful night sky. And not only are we going to talk about telescopes and how they work, we're going to talk about these telescopes and how they work. The most familiar telescopes are the optical telescopes. These telescopes work with visible light like our eyes. An optical telescope, a mirror or lens, collects the light that uses to form an image. The small telescopes by amateur astronomers have eyepieces containing small lens for viewing the image. Telescopes perform three main tasks. 1. They produce images of distant objects. 2. They find objects that are too faint to see with the unaided eye. 3. They gather light for a CCD camera. What is a CCD camera? This is an amateur CCD camera. How does the CCD camera work? It's an electric eyepiece that hooks into a TV or a computer. This is a reflecting telescope. This is my dad's first telescope when he was a kid. At the top of the telescope, there is a lens called an objective lens. On the bottom of the tube, there is a small lens called an eyepiece. Galileo was an Italian astronomer who was the first to use a telescope to observe the sky. In 1609, he observed the rough surface of the moon, nebula regions around the stars, and the individual stars of the Milky Way. In 1610, he was the first person to observe the full moon around Jupiter. He also developed and improved a reflecting telescope, but he didn't invent it. This one has good resolution, but this one has even better. This is a reflecting telescope. Light enters the telescope, bounces up the primary mirror, comes out the lens into the eyepiece. The 200-inch telescope on Mount Palomar is a reflecting telescope. I went up to Mount Palomar to see this telescope for myself and see how it's like my 4-inch telescope. My telescope is much like the big eye at Mount Palomar. Let's go up to see and take a look. Hi, today we're at Mount Palomar, and as you can see, we're 5,550 feet, and we're going to look at the Hill 200-inch telescope. Do you wonder why the 200-inch Hill telescope is called the 200-inch Hill telescope? Because the mirror is 200 inches. How big is 200 inches? Well, I'm sitting on it. This is the model of the 200-inch Hill telescope's mirror. Now let's go outside and see the real 200-inch Hill telescope. This telescope was built in the 30s, and it's known as one of the largest telescopes in the whole world. This is the telescope's dome, and when it opens up, the dome spins around, and then the two doors on the top open up behind it, and then it sticks the telescope's frame out for you can see the night sky. The dome also spins around 360 degrees. That way it can point anywhere in the night sky. The 200-inch telescope is named in the honor of George Henry Hill. let's check out this baby now. The Palomar telescope is also nicknamed the Big Eye because of its large 200-inch primary mirror. These are the wheels that the dome rolls on. Going up to see the Big Eye was interesting and fun. I learned about the 200-inch mirror and how it helps magnify images 1 million times better than our eyes. That's how they get those great space pictures. Now let's see how it all works. This is the light path that follows through the Hale reflecting telescope. Light enters the telescope's frame through the dome and reflects off the 200-inch primary mirror. Then to a focal point back on the top of the telescope, a CCD camera captures the image. The telescope is aligned to the celestial North Pole. This is by the North Star. The telescope moves from the celestial north to the south on its declination axis. Moving the telescope like this helps keep the telescope fixed on an object by just moving the telescope's other axis. The right ascension axis is used to follow objects in the sky. A clock and a motor moves the telescope at exactly the same speed the Earth's rotation makes the stars move in the sky. An astronomer does not have to adjust the scope very much when studying an object. Hi, welcome back to Palomar. And did you know the 200-inch telescope is pretty much like an orange telescope? Light enters the telescope, bounces off the primary mirror, comes out the lens called an eyepiece. The 200-inch telescope does not need an eyepiece. It needs a CCD camera. This one needs an eyepiece, but it can use the CCD camera too. This is the clock motor. It helps track stars in the sky. This is a remote control that controls the clock motor. This is the right ascension axis. This is the declination axis. Pretty much like the 200-inch telescope, huh? Most important thing to know about telescopes is that how much it magnifies is not as important as in how clear the image is. This is called the telescope's resolution. To get the best resolution, you have to have a large primary mirror or lens. I have an example of this on the display. Telescopes help us study the sky and see its wonders. A kid like me can make a great discovery in the sky, just like a professional astronomer. Maybe I can discover the next great comet like the Hale-Bopp comet. Well, I'm gonna look at the stars for a while. See you inside. Today we got to talk about telescopes and how they work. You also saw the difference of a refracting telescope and a reflecting telescope. We got to take a trip to Mount Palomar to see the 200-inch telescope and how it works. I hope you enjoyed my program. Please check out my telescope display. Thanks again for joining me in this science project. This is Daniel Pena, young astronomer, saying goodbye from the 2004 Science Fair.
I wish that I could fly into the sky so very high, just like a dragonfly. I'd fly above the trees, over the sea.